All right, let's talk about the JAKA Palletizing package. If you've ever wanted a quick, no-nonsense guide to get this thing commissioned from start to finish, well, you're in the right place. We're gonna walk through everything you need to know to get it up and running safely and efficiently.
Okay, so here's the plan. We'll start with the basics you need to check before you even begin. Then we'll jump into defining the workspace, creating the actual pallet plan, teaching the robot its path, and we'll wrap up with the really critical safety stuff. Sound good? Let's dive in.
All right, first up, before you begin. You know, getting this initial prep work done right is honestly the secret sauce to making the rest of this entire process go super smoothly. Okay, so before you touch a single setting, you gotta check your software versions. Make sure your controller is at version 1.7.228 or higher, and your Kobo Pi system is at least version 2.1.7. As for the robot itself, JAKA suggests going with something that has a bit more reach, you know, like a Pro 16 or a Zoo 20. It just gives you way more wiggle room with your layout.
Now, installing the actual package, it's a piece of cake. The JAKA Tech team will send you a .tar file. All you gotta do is hop into Kobo Pi, go to JC app, then package, hit import, and boom. Just select the file, let it do its thing, and then make sure you enable it to get started. So, once you're all installed and enabled, this screen right here becomes your command center. This is where you'll tell it if you're working on the left pallet, the right one, or both. You'll load up your saved plan, which, by the way, they call a formula, and of course, this is where you'll hit start and stop. Pretty simple, right?
Okay, software's good to go. Now for the fun part, teaching the robot about the real world. We've got to connect all those digital commands to actual physical actions. And the first stop on that journey is the robot's own tool.
So, let's talk about the TCP. That stands for Tool Center Point, and it's basically the robot's virtual fingertip. It's the one single point that the robot thinks of as the very center of its gripper or suction cup. And you have to get this right. I mean, if it's off by just a tiny bit, every single pick and every single place will be off. It's absolutely fundamental. And this here shows you exactly what I mean. See on the left? That's where you punch in the numbers, your X, Y, and Z values. And on the right, you see how that translates to the actual physical gripper. It's a direct one-to-one map. What you type in has to perfectly match the reality of that tool.
All right, so the tool is defined. Next up, the target. We need to tell the robot exactly where the pallet is in 3D space. And we do that using something called the Pallet User Coordinate System.
Now, there are a few simple rules here, but they're really important. The big one is consistency. You have to keep the orientation of your coordinates the same. Don't go flipping the X or Y directions around. All you want to do is adjust the position values. So you'll tweak X and Y to tell it where the pallet is on the floor, and you'll tweak Z to tell it how high the pallet is. Just don't mess with the orientation.
All right, this is cool. The robot knows its hand, and it knows its target. Now, let's give it a job to do. We're gonna create what JAKA calls a formula. Think of it like a reusable recipe for stacking a specific box on a specific pallet. And making one of these formulas is super easy. It's really just 3 parts. First, you tell it everything about the box, its size, its weight, how much space you want between them. Second, you tell it about the pallet, its size, how many layers you're gonna stack. And third, you pick the stacking pattern. That's it.
So for that stack pattern, you've got 2 main choices. You can go with System Recommended, which is awesome for getting set up fast. The software just figures out the best patterns for you. Or if you have a really specific layout in mind, maybe with some odd rotations, you can choose Manual Config and get total control over every single box.
And honestly, that system recommended option is a lifesaver. You just plug in your box and pallet info, and it spits out a whole bunch of optimized patterns for you to pick from. For most jobs, you probably won't even need to touch the manual mode. Okay, let's keep moving. Next, we have to actually teach the robot the path it's going to take. We're going to set up the key waypoints that define its entire journey, from picking up a box to placing it on the pallet.
So you'll physically move the robot around to teach it a few key spots. You've got your home point, which is just its safe, at-rest position.
You've got the pick point, which is pretty self-explanatory, and then you have these super important transition points. Think of them as a safe flyover point between where it picks and where it places.
Now, I really want to double down on those transition points. Their location is everything. You have to position them completely outside the area where the final full stack of boxes will be. Why? Because if you don't, the robot arm might try to take a shortcut right through a spot where a box is supposed to be later, and that's how you get a collision. So yeah, create a nice, high, safe air bridge for it to travel over. Okay, so at this point, we've got a working robot. It knows what it's holding, where it's going, and the path to get there. But working isn't the same as working safely. So now we're going to talk about the settings that make this whole thing safe and reliable, especially when you start cranking up the speed. So I've got a question for you. When that robot is flying towards the stack at full speed, what is the single most important setting that's going to prevent a very expensive crash? The answer? It's called safety clearance, and what it does is brilliant. It's basically a virtual buffer zone. It tells the robot, hey, before you go to the final placement spot, you have to stop at this safe distance above it first. This forces it to slow down for a careful final approach instead of just slamming into place at high speed. It's your #1 defense against overshooting.
And here's how it works in practice. The math is super simple. Your safety clearance plus the box height equals the approach height. That approach height is the exact point where the robot hits the brakes and begins its final, careful descent. You pair this with your safety speed and acceleration settings, and you have total control over that critical final move.
And that's the whole shebang. See? It's a really logical flow. You check your versions and import the package. You configure your workspace with the TCP and pallet coordinates. You create your formula, teach the points, and then you lock in those all-important safety settings like clearance and speed.
Here are examples for adjustment. You will see the signal settings have been assigned perfectly for you. You don't need to adjust anything, only select which signals you prefer to use or not. Next, the tool setting, which is your TCP setting and gripper information, included the waiting time when pick or place the boxes. The point setting for you to assign the position needed for the palletizing station. Next is the distance and speed setting for you to assign distance and speed for avoiding the boxes gotten collision to each others. It is really important for you to select speed perfectly. General setting is for you enable the safety clearance, the shim pick and place, movement in pick to pallet waypoint, and select where you want to put the box first. You can check on the right picture which coordinate you want to start first. Starting with 0, 0, 0, 1, 1, 0, and 1, 1. Conveyor setting, at here you can teach your picking point position. Remember that you must talk the position above conveyor, not the box, since the robot will automatically adjust the picking position following the project box meaning. And it is very important to select the pick point compensation distance correctly. At the picture, you will see 4 types of possibilities coming boxes. For starting after we finished setting up everything. First, manually verify that the empty pallet is in position. Select palletizing box project models for left and right pallet. Second, click the Start button to load the program. Third, if you want to start left pallet, you can push the left pallet 1 time and wait 3 seconds, and push at the same button for starting. If you want to start with right pallet, you can push the right pallet 1 time and wait 3 seconds, and push at the same button for starting. That's the complete setup flow.